Shadow maps are a very efficient means for interactive rendering of shadows. A shadow map is obtained by rendering the scene from the view of the light source in a first pass. The resulting depth buffer then becomes the shadow map. A point is considered to be in shadow if its light source depth is larger than the corresponding shadow map depth. For large scenes in particular, standard shadow maps suffer from aliasing problems. The problem is that the perspective view changes the image size of objects according to their viewing distance. This cannot be achieved by a uniform shadow map. Perspective shadow maps are constructed in post-perspective space. In this space, the viewing frustum is mapped to a cube. The final perspective image is a parallel view of this cube. Object sizes directly correspond to their final image size. In post-perspective space, directional light sources can become point light sources and vice versa. Here we see a moving parallel light source which becomes a moving point light source in post-perspective space. We then generate a standard uniform shadow map in the post-perspective space. The resulting shadow map exhibits high resolution in the nearby regions and decreased resolution in the back. The improvement in shadow quality is dramatic. Problems arise when a light source is moved behind the viewer. In this case, objects behind the viewer can cast shadows into the current view. In post-perspective space, objects behind the viewer show up beyond the infinity plane. Here we see these trees on the left. The shadow of one of them must become visible. We account for this by virtually moving the view frustum backwards for the shadow map computation, such that all potential occluders behind the viewer are included. To obtain optimal results from perspective shadow maps, it is important that the near plane is as far as possible. We enforce this automatically by reading back the depth buffer after each frame and adapting the near plane accordingly.